Hola guys, in this video we are going to discuss problem 49 electric charge and field topics. So this is the question taken from the Giancoli's book Physics for Scientists and Engineers, right? So a thin rod is bent into the shape of circle arc of radius r carries uniform charge per arc length, or charge per length equals to lambda. So determine the electric field at origin. So this is the diagram as you can see. Okay, so this is the thin rod being bent, right? So this is the thin rod being bent. So the angle theta at the top and the bottom region are the same, so which means there are symmetry along the x-axis, right? Along the axis, right? So first of all, we need to consider the small element of the charge, right? So this is the whole is the positive lambda, but we need to consider the small element of charge and also the small element of dE, okay, so that we can integrate from negative theta to theta later on, right? So by that sense, okay, we can consider like this. Okay, so this is small angle which is d theta, which we consider, and of course this whole thing is ds, right? So the small element is basically ds. Okay, right, so I just consider at the bottom, at the top region, because they are symmetry, so I don't have to consider both of them. Okay, so if you realize that the net electric field will be to the right, and also the y component of the electric field will cancel out, right? Because the bottom part has the electric y component like this, right? Electric field like that, and then the top is like this, so they are cancels, right? So by that sense, we can draw a conclusion that the E total, is just the E, okay, cosine of theta. Okay, so because only the x component, the horizontal component, which is E cos theta. So we know that E is base, so basically we can consider the E is just what? Okay, 1 over 4 pi epsilon naught, okay, Q over R square. Okay, so in differential form we have dE, because we are considering the small part or the small region, so dQ is what? 4 pi epsilon naught R square. Okay, so we need to find the relation between ds and also d theta, but from this we know that Q equals to lambda s. Okay, Q equals to lambda s, which makes that dq, a small element of dq, lambda ds, right? But if you still remember, okay, from the mathematics high school class, okay, so this is the circle of radius r and also center O, and this is basically alpha, for example. We want to find what is the length of the arc length over here, which is given by s, for example. So s is, and also the radius is r, for example. S is basically r alpha, r times the angle alpha, right? So by that sense, we know the differential form for that is, okay, so from here we know that ds is basically r times d theta, like that. So ds is that, so we can substitute into our equation dq. Okay, so we can substitute this, okay, as r d theta, like that. Okay, then we can substitute into our first equation, which is this one. So E total which is E times cos theta. So E total is just in differential form, which is dE total times dE cos theta, which is dQ. dQ is lambda r d theta, lambda r d theta over 4 pi epsilon naught r square, and then don't forget the cos theta, which tells us we are only interested in the horizontal component. And then we want to find the total, not the differential part, so we need to integrate from minus theta to theta, minus theta to theta. Okay, so first we cancel this and that. Okay, so we can get our E total is just, so we just pulls out the constant, lambda over 4 pi epsilon naught r, so lambda integration minus theta to theta cos theta d theta. So this is easy. So lambda over 4 pi epsilon naught r, 4 pi epsilon naught r. Okay, integration of cos theta is sine theta from minus theta to theta, which will equivalent to sine theta. So we will get 2 sine theta, right? If we evaluate the integral limits. Okay, 4 pi epsilon naught r. So what we can do is we can cancel the 2 and the 2. So we'll get lambda sine theta divided by 2 pi. Okay, we still have 2 epsilon naught r. And this is our E total. Okay, yeah, so let me check if I did any mistake. Okay, there's r. So yeah, alright, so yeah, I think that's correct. Okay, so yeah, that's all from my video. Alright, so thank you and good luck.